In today's lesson, we're going to focus on geology, which falls in the category of earth science. We're going to look at the study of rocks. We're going to learn about the three kinds of rocks: igneous, sedimentary, and metamorphic. We'll talk more about all of those in detail once we go out into nature. I love noticing all of the different kinds of rocks that I see on my walks in Big Bear. Big Bear is a valley in the San Bernardino Mountains, and this mountain range formed about 11 million years ago because of earthquakes. And it runs along the famous San Andreas Fault. And because these rocks were actually pushed up to the surface of the earth because of earthquakes, the rocks themselves can even be like 1.7 billion years old. And when you think about that, it means that you could literally be holding a rock that dinosaurs walked on. You could be walking along and then all of a sudden there's this giant boulder and it's so fun to climb on them. Did you notice how the colors are changing and the textures are changing? Like this rock formation is very yellow and orange and the rock looks very smooth, while some of those other rocks we just saw were dark gray. Or here are ones that are very light gray and white and they look layered, almost like they're piled on top of each other. What I'm showing here are the little pieces of rocks that are broken up because of erosion and weathering over time, creating just like sand. And so whenever I'm around boulders that I'm climbing on, I always notice how much of this granite rock is actually all over the ground. Let's take a closer look at the three main types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks, I gave a little symbol of a volcano. The name comes from the Latin word ignis, which means fire. And igneous rocks are formed from the magma or the lava when it cools. And so you can find them all over the world. They're everywhere. There doesn't have to be a volcano there, but they're usually near volcanic hotspots, and they can be brought up to the surface through earthquakes as well. An igneous rock is from a volcano and from magma. So for an igneous rock, you go rock and then have the volcano erupt and the lava land. So like that. So igneous rock. Sedimentary rocks got their name because of the Latin word sedere, which means to sit or settle down or be seated, and sediment, which are little small particles of sand and gravel, settle down. They get compacted and they kind of sit on top of each other in layers, and slowly over time, they're compacted into sedimentary rocks. Sedimentary rocks often have formerly living particles in them as well. They'll have fossils in them and little pieces of shells or bones inside of them. For a sedimentary rock, which is layers and layers and layers of small pieces of rock, you would have the rock and then show layers. So sedimentary rocks. For metamorphic rocks, I put a little picture of Morpheus because metamorphic rocks come from the word meta, which means to change, plus morphic, which means to form. So these rocks change form. Metamorphic rocks can be made from sedimentary rocks that have gotten buried back down under the Earth's surface, or igneous rocks, or even metamorphic rocks getting buried deep within Earth's crust again, where the pressure from tons and tons of rocks on top of them are pushing down, and that's combining with the heat rising up from hot magma underneath them. And this causes these rocks to get flattened and folded and rearranged into new layers and even change their mineral content. Now, if any of these rocks get buried so deep and so hot that they actually melt again, then they'll turn into an igneous rock instead. But if they stay just right where they're getting that heat and that pressure, they'll transform into metamorphic rock. Metamorphic rocks are rocks that have gone through a change. They've maybe mixed with other rocks, or they've actually changed their chemical properties and even their physical properties. And it all happened through pressure and heat. So we're gonna go rock and then show change. This is the sign for change or transformation. So one hand is up, the other hand is below, and then they trade places. And the other hand is up and the other hand is below. So metamorphic rock, metamorphic rock. The three different types of rocks change and work together in the rock cycle. It happens over millions and billions of years. None of this is happening quickly. It takes time for rocks on the surface to get pushed through plate tectonics and earthquakes back down under the earth again. And it takes time for those rocks to go through their process under the earth and then come back up onto the surface of the earth again, either through a volcano erupting or through an earthquake pushing them back up again. And then, of course, even when they're on top of the earth, it takes a long time for weathering and erosion to happen to turn them into sedimentary rocks. So this whole process is millions and millions of years of work. For our hands-on activity, we're going to create a model simulation of the rock cycle, including sedimentary rock, metamorphic rock, and igneous rock. Now, we're going to start off by just imagining that this one piece is an igneous rock, and I'm just going to put it aside because we're going to need it a little bit later. First thing you need to do is take about 3 Starburst candies, and you're going to need a baggie a little later, and you're going to need some tin foil a little later. Just a piece and a baggie is fine. Your parents can help you with this. You can also just peel it apart with your fingers. But our goal is to create a sedimentary rock, which means we need to create a bunch of little pieces, small pieces of pebbles and sand that have been carried down rivers, blown by weather erosion, and they're going to accumulate. And so we need those little pieces so that we can create our first sedimentary rock. So now that we have a bunch of little pieces of sand and gravel, sedimentary rock are these pieces coming together again. We're compacting, like pushing it together. All the layers of the sand and the gravel have come together and they are being compacted into a sedimentary rock. Okay, next in the rock cycle, we're going to look at a metamorphic rock. A metamorphic rock is more than one kind of rock that has gone back deep into the earth, under the earth, and combined through pressure and heat to make a whole new rock. So let's say this is a sedimentary rock and this is an igneous rock, and they both end up together deep in the earth. And you can put this in a baggie, and we are going to simulate, that means sort of like model and show, pressure over time and heat over time and forming a whole new rock. So I'm going to use the heat from my hands to simulate the heat that is deep in our earth. And I'm going to use the pressure by pushing down, smashing it down to show the pressure that is happening. It looks like a whole new rock of its own, our metamorphic rock. To model and simulate our igneous rock, we need to create quite a lot of heat. So we are going to create a little tinfoil boat. Metamorphic rocks and sedimentary rocks can go back deep enough to turn into an igneous rock, actually. But the idea is that it's going to be so hot that it's actually going to melt into magma. And that is melted rock deep, deep, deep in our earth. So we're gonna actually take this over to the stove and we're gonna cook it. I've created a little tinfoil boat. Mommies or daddies are gonna help us put the stove on at a nice low temperature. We're gonna set it into our pan and observe as it heats up. It's taking its time, just like most geology. It's hard to imagine that this liquid magma or molten lava, when it's on the surface, will cool and harden again into a solid rock that we call an igneous rock. I'm going to turn off the heat let it cool, and see how it turns out. Our igneous rock has cooled down enough. It was magma, molten lava before when we heated it up. Remember it bubbling and boiling as a liquid? And now it is cooled and it is our new igneous rock. Some possible assignments, if you choose to accept them, are to write an essay about the 3 types of rocks and the rock cycle. You might want to draw a poster and draw out each type of rock and some of their features. And then, of course, you can do the starburst activity, or if you can't get your hands on starburst, it's supposed to work with crayons as well, but you might want to look that up on YouTube. See you next time.